Let's talk t-tests. In a t-test, you're using the statistics that you have available to you to go from sample information to a broader conclusion about the world. So let's start out with a single sample t-test. The way that this works is you're basically comparing the mean of your sample to some kind of benchmark, some value that you think would be the mean of another population or the mean of the population at large. Okay, so you're basically picking a comparison point all on your own, even though you don't have access to what the standard deviation around that is likely to be. What we know is that we use the math to go from our sample information to this bigger conclusion. But in SPSS, it's just so simple. So here we are in the new drug dataset. We're up here, newdrug.sav. If you're not there, you can open it up straight from the file and you'll end up looking at something like this. And this was a study that was testing between control and people taking this new drug. Was there a decrease in people's blood pressure before to after? But for a single sample t-test, let's start out with a very simple question. And let's just think about the before case. Before people took either nothing or this new drug, this was their blood pressure. And let's say that our goal is to get blood pressure down to a level of 90. And we want to know, how are they really that much higher than 90 now? Or is it not a significant difference? Are they already on average around where we think that they should be? Okay, so 90 is our benchmark, our comparison point, and here is our actual set of data. To do the single sample t-test, all you have to do is go up to Analyze, Analyze Compare Means. I just recorded all the descriptive statistics videos. Compare Means, and then the one sample t-test. Okay, single sample, one sample, all the same thing. Click on one sample t-test, and it'll bring up a window that's now familiar to you where you have all your variables over here and then your test variables over here. But we would just want to test before blood pressure. And here in test value is where we're going to put in our benchmark, our comparison. So we want to compare whatever their before average is to a value of 90. Okay, we think 90 is a good place to be, and we want to know, are they significantly above that at the moment? So we just click 90. That's the mean that we're comparing it to in theory, and we have our actual data, and we hit OK. And there we have it. You can see up here in the first table, it gives us the N, of course, 50 people. The mean of the first before blood pressure, 98.3, which sure seems like it's higher than 90, but not sure if it's significant. And then we get the standard deviation, which is 5.17. Don't worry so much about standard error for now. Here then is the one sample t-test, where t that we compute is 11.36. That's when we kind of take our sample mean and we fit it into our distribution given this degrees of freedom, right? 49 is our degrees of freedom because 50 minus 1 is equal to 49. And here we see our significance level. Now this is the p-value, the actual p-value. What you can see here is it's so small that it can't even show us any of the numbers, right? It's less than 0.001. So if we were to use a t-table, we could look up what the cutoff level would be for p is equal to 0.01, let's say, and this t-value is definitely way bigger than that, right? This also shows you that it's a two-tailed test, and you're testing the significance in a two-tailed way, but you don't even have to specify p equals 0.05 or 01 or 10. It'll give you the exact value. Okay, and that's all that we're concerned with for now. So what we can conclude from this is that we reject the null hypothesis that there's that people start out with a blood pressure not any different from 90, and we reject it, and we have now some support for the idea that people in this group had significantly higher blood pressure than the ideal value. Let's do one more just to throw a wrinkle in this. Let's go up again to Analyze, Compare Means, and then the one sample t-test. Let's hit reset. And now let's say after they took the drug, overall across both of the control and the new drug conditions, after they took it, was their blood pressure still significantly different from 90? If 90 is our benchmark, let's find out. So we click this, put it over here. Our test value is still 90. But now I just want to show you another thing that you can do. So if you go into options, this is where you can, well, no, this is not what I thought you could do. Okay, never mind. Never mind. Cancel that. I thought you could do a one-tailed test, but I suppose not. All right. Either way, let's go ahead and roll with it like this. Hit OK. And we'll see again here. So now this is the after picture, where now t is equal to negative 2.17 because we're actually under, right? This is negative because our actual mean is less than 90, right? But just a little bit. So now we wonder, well, is it significantly less? And we can see here our significance is now not as tiny as before, but here p is equal to 0.035. So if you're using 0.05 as your significance level, that means that you reject the null hypothesis. But if you're using 0.01, you couldn't reject the null because this is still above 0.01. So it just comes down to how you want to interpret this particular test. Okay, so in two cases, we see that all we're doing is comparing the mean of our sample to some predetermined comparison score. Okay, in this case, the comparison was 90, but you could have used whatever you chose. We just used 90 because it happened to make some sense, all right? And we're testing the significance in terms of how different the mean is from that value.